Hello and welcome to another video. In this video we're going to be working on construct k palindrome strings. And in this one you're given a string s and an integer k, and you want to return true if you can rearrange the characters in s to make k palindromes. So in this first one you can rearrange like this or like this or like this. In the second one you can't, we'll talk about why. And in the third one you can basically have palindromes of length 1. So basically the key to a palindrome is you can only have at most one unmatched character, right? If it's even, every character has a pair, and if it's odd, there's one unmatched one in the middle. So let's look at this LeetCode thing, and let's get character count. So we have like 1L, 2 E's, 1 T, 1 C. Actually we have 3 E's, and then O, D. So this is our character counts. And we can't have more than one unmatched character. So for all of these characters that there's only one of, they have to be in a separate palindrome. So like this L has to be in a separate palindrome. So like L would have to be in a separate one, T would have to be in a separate one, C, O, D. And also in this E, there is one matched E, but there's one that's not. So an E would also. So you would have to make 6 palindromes or more, because all of these unmatched characters have to be separate. So to use every character, you have to make 6 or more. And then the only ones that we can actually move around are this pair of E's that we have left. So for example, we can put a pair of E's like here somewhere. You know, we can have like ELE, we can have ETE, we can move it over here, over here, over here, over here. So any pair you can move around wherever you want. And also you can split any pair into 2 characters, right? So for EE, we can either put it somewhere, or we can just say like, we can just do this. So this is kind of like the key to this problem, is to realize that all unmatched characters have to be a separate word. And so we can actually just count this up, right? We can just get character counts and figure out like, okay, take every character count, mod by 2, how many unmatched characters are there? At most there can be 26. So that's how many characters you can have. So the lower bound of k is basically count of unmatched. Now what's the upper bound? Well, the upper bound is everything else we can either put wherever we want, right? Like let's say we have like 10 unmatched characters, and let's just say we have like 100 pairs. Well, we can take as many pairs as we want and add it to one word. Like we can have like an A and put like 50 pairs here, right? We can have like BB, CC, whatever, and then put an A in the middle, and that's a palindrome. So that's another important thing, is for the number of matched pairs, we can take any number of pairs and put in any of the words. And we can also take a pair and just break it into its separate word, right? So if we have a pair like AA, we can just say like, this is 2 words. So what's the upper bound? Like if we have 100 pairs and we have 10 unmatched characters. So the upper bound is actually, we can just take all these 100 pairs and break them down into individual characters. So it's actually just going to be 200. Plus this. So the upper bound is like this. This is going to be pairs times 2, because we can break them down, plus this original unmatched, so 10. And this just turns out to be the length of the string, right? Like a string is going to have either pairs or single characters, and then this is going to be the length of the string. So this just ends up being the length of S. And so now that we know that equation, we can basically just say, okay, well, number unmatched. Now all we have to do is just go through the word, get a count, figure out how many unmatched characters are there, and make sure k is in between this thing, and then we're done. So kind of hard to figure this out. If you've done a lot of palindrome problems, I've done a decent amount, I can like figure it out. This is like the main thing you want to look for, is you can't have single characters together. You can move pairs around depending on the problem. So yeah. And then figuring out this upper bound is also not super easy, because you can realize like, okay, I can take every pair, break it down, or move them wherever. So the upper bound is just the total length of the string. But this is essentially what we're looking for. So now all we have to do is code that. So we're just going to get like a count. We can use an array. So this is just going to be a length 26 array. And then we can go through every character. So So this is going to be counts of s at I normalized by subtracting a, just like a bunch of other problems. This. Now we basically have to count our number of single characters, so we can call this like singles or something. And then we can just loop through all of the values and counts. So and here we can just check if that value mod2 is 1, then we have an extra. So we can just say essentially this. If this 1, we'll add 1. If it's none, we'll add none. And for every character, you can have at most 1 extra. Otherwise, I mean, if you can only have a pair of singles, you can't have, like, yeah, for A, for example, we can't have more than 1 extra A. Otherwise, it'd make a pair. So now we just have to return our equation. So return singles. I don't think you can do this all in one line, so you can just say singles less than or equal to k, and k is less than or equal to length s. Like, we actually have to have enough characters in the string. And that should be it, I think. Let's see. I think we can just do this. Okay. And there we go. So the nice thing about having these formats, also having character counts, is this is basically of one space. Talked about this in a bunch of other problems. You can only have 26 characters, so this is of one. So time, we're essentially going through the string, which is n. Now we're going through the counts. Counts is only 26, so this is constant time. And then this is obviously constant time. So yeah, so that's going to be all for this problem. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.